Welcome to the first part design tutorial of this course. In this tutorial we will create the nose gear fork for an aircraft. The tutorial is split up into several steps. In each step we will show you a model on the left and you will create it on the right. The first step is to rename the part and 3D shape and give them a description. Right-click on the top of the model tree and select Properties. Under the Reference tab, fill in the title and the description, and then click OK. Repeat the procedure for the 3D shape. A sketch is the basis of almost all elements in CATIA. In this step we will create a sketch on the XY plane for the first pad. In the Essentials toolbar, click the Position Sketch command. Next select the XY plane either in the Geometry window or the Model tree. Create a circle where the center point is coincident with the sketch origin. As can be seen when you hover over the origin, the blue circle shows that an automatic constraint will be created. Now if we drag the circle, it will change its size, which we do not want, so we will add a constraint to dimension the diameter to 40 mm. Start by clicking on the circle, and then in the contextual menu, click the constraint option. Click in an empty space to create the constraint, and then enter in 40 as the value for the length. As you can see after creating the constraint, the color of the circle is now green, showing that it is fully defined and cannot move anymore. In CATIA this is known as ISO-constrained. If we use the Sketch Solving Status command in the Analysis toolbar we can confirm that the whole sketch is ISO-constrained. During the course all sketches must be ISO-constrained. Exit the sketch once you are finished, using the Exit App command. All 3D parts are made up of features that can be combined to create more complex geometry. In this step we will extrude the sketch into a 3D solid using the Pad command. Select the sketch from the previous step in the model tree. In the Essentials toolbar, click the Pad command. In the Pad dialog, under the first limit, ensure that the type is set to dimension and then change the length to 100 mm. Expand the second limit and use the dimension type as well, but this time with a length of 170 mm. Click Preview to see the result. Then click OK to create the pad. We will now create a second sketch, this time on the YZ plane. In the Essentials toolbar, click the Position Sketch command. Next select the YZ plane, either in the Geometry window or the Model tree. Using the Profile command, we can make continuous straight lines with arcs in between. We will start at the top left and make the first horizontal line to the right. To make a tangent arc, click and drag the mouse downwards to start the arc. Or use the Tangent Arc option in the Tools palette. Notice that CATIA will automatically create constraints depending on where you place the geometry. This can be seen when the geometry is highlighted in blue. Keep this in mind so that you do not create unwanted constraints. Continue creating the profile as shown in the image. Make sure that the radii do not have the same center point. Do not worry about getting the geometry exactly as shown in the image, as we will use the constraints to define it precisely. In this case some lines did not get the vertical and horizontal constraints. By right-clicking on the line and going to the Object menu, we can manually set the orientation. Next, we will create the line between the two end points of the arcs. Add a vertical constraint if your points were not lined up correctly. Now use the contextual menu to change the line to a construction element. A construction line is used to help define the sketch, but you do not want it to be used when creating a 3D item. Now we will create the dimensional constraints on the geometry and set them to the correct values. By selecting different geometry, we can create different types of constraints. Create all the constraints as shown in the image. Finally, we can position the sketch by making the vertical and horizontal lines coincident with the axis and lower edge of pad 1. When creating a constraint, the type of constraint can be changed with the contextual menu as well, or by right-clicking and selecting a different option. In this case, we will use coincident constraints. As you can see with the green coloring of the lines, the sketch is now fixed in position, and we will use the sketch solving status command to check that it is isoconstrained. Exit the sketch once you are finished using the exit app command. Using Sketch 2, we will now create a second pad for the lower part of the fork. Select the sketch from the previous step in the model tree. In the Essentials toolbar, click the Pad command. In the Pad dialog, under the first limit, ensure that the type is set to dimension and then change the length to 25 mm. Now apply the symmetry option to add material on both sides of the sketch. Click the Preview button to see the result. Click OK to create the pad. In this step, we will use a tritangent fillet to round off the bottom of pad 2. In the Refine toolbar, click the arrow next to the Edge Fillet command to bring up the extra tools. Select the tritangent fillet option. Now select the two outer faces of pad 2 as the faces to fillet. Next, click the bottom face of pad 2 as the face to remove. Click Preview to see the result. Finally, click OK to finish. We will now use the Draft command to angle the sides of the fork. In the Refine toolbar, select the Draft command. In the Draft dialog window, change the Draft option to Reflect. Change the angle to 3.5 degrees. Next, we will select the rounded edge of the tritangent fillet as the face to draft. Reverse the pulling direction so that it points in the -z direction by clicking on the arrow shown in the geometry or by clicking the reverse direction button. Click Preview to see the result. As you can see, it will make the top of the pad wider. Click OK to create the draft. In this step, we will remove the bottom face of pad 1 so that it connects correctly to the top of the draft. If you look closely at the intersection of the two pads, you will see that there is a small gap. In the Refine toolbar, click the Remove Face command. Select the bottom surface of the pad as the face to remove. Click OK to finish. You will see that the gap in the intersection has now been removed. In this step, we will create a hole in the bottom part of the fork for the axle to fit into. Since we want the hole to be concentric with the rounded edge, we will use it when creating the hole. Select the rounded edge of the fork so that CATIA knows to place the hole concentric to it. In the Essentials toolbar, click the Hole command. Now select the face of the fork on which we would like the hole to be placed. Change the limit type to Up to Last to make it go entirely through the part. Next, change the main diameter to 20 mm. To check that the location of the hole is correct, click the icon next to Positioning. This enters us into the positioning sketch for the hole. The center of the hole will be located at the point which is automatically created in the sketch. Since we selected the rounded edge to position the hole, a concentricity constraint was automatically created and therefore the sketch is isoconstrained. If you do not have the constraint, and the point can move freely, then you will need to manually create one. Select the point and the rounded edge, then in the contextual menu click the constraint option. Change the constraint type to concentricity. Exit the sketch to go back to the hole creation. Now we can click Preview to see the result. Finally, click OK to create the hole. In this step we will round off some of the edges using the Edge Fillet command. In the Refine toolbar, click the Edge Fillet command. Since we used the Tritangent Fillet command in a previous step, the Edge Fillet will be underneath it in the extra commands. In the dialog box, ensure that the radius is set to 5 mm. Now select the three edges of the fork which are shown. Ensure that you select the edge and not the face of the part, as this will give a different result. Click Preview to see the result. Finally, click OK to create the edge fillets. In this step we will remove a part of an edge, similar to using an edge fillet, however this will be a straight cut instead of a rounded one. This is known as a chamfer. In the Refine toolbar, click the chamfer command. Select the top edge of the fork as the object to chamfer. Set the length to 2 mm and the angle to 45 degrees. In this case the direction of the chamfer does not matter due to the angle being 45 degrees. Click Preview to see the result. Click OK to create the chamfer. In this step we will add some materials to the part and then compute the weight. In the Tools toolbar, click the Material Browser command. This command brings up the search window. Use the Restore Down button in the top right and resize the window, so that we can see the model tree and geometry. In the search bar, type in name of the material to be used, in this case the core material is cast carbon steel. In the 6W tags, under Source, choose the public database as the collaborative space to search in. If you do not see the tags column, click the 6W tag button next to the search bar. Find the cast carbon steel core material. Click the arrow on the right-hand side of the tile and then select Apply in the menu. Click on the part at the top of the model tree. In the contextual pop-up, make sure the material is applied to the part, then select the green check mark to apply the material. Next, search for the chroma polished covering material. Click the arrow on the right-hand side of the tile and then select Apply in the menu. We want to apply the covering material to the inside face of the hole for demonstration purposes. However, if we select the hole, it will give us the axis instead. Thus, we need to right-click the face and select Other Selection. In the dialog box, select the face option. Then, in the contextual pop-up, make sure the application on face option is selected, then click the green check mark to apply the material. As you can see, the material are now shown in the model tree. Note that the chroma polished is applied to the face. We can now close the search window. Remember that if you cannot see the material on the geometry, you need to change the viewing mode to Shading with Material in the View toolbar. As you can see, the hole has a different surface texture to the rest of the part, but in this case this is only used as a visual representation, showing that the hole will be machined, as well as how covering materials can be applied to different geometry. Now we will compute the weight of the part. First, we need to activate the part product by double-clicking on the top of the model tree. Note that this will change the app to the assembly design. If not, use the compass to change the app to assembly design. In the Tools toolbar, click the BI Essentials command. In the pop-up window, select the weight definition from the drop-down menu. Click on the part and then select the second hyperlink in the pop-up to compute the weight. Click the Update command at the top of the weight table to refresh the values. As you can see, CATIA computes the inertia values for the part. Close the weight computation and the BI Essentials. In the next tutorial we will create the drawing for this part, so we will add one. Make sure the part is the active product, then right-click it in the model tree. Under Insert, select Drawing. Right-click the newly created drawing and select Properties. Fill in the title and the description shown in the text. Click OK when you are finished. This is the end of this tutorial. Save your part by clicking on the Share button at the top right. Then click the Save button to save the part. Note that a suffix is added to the end of the part name. This shows the revision of the part and that the part is in the database. It is recommended to save regularly, to be sure that you do not lose progress in the event of a software or hardware failure. The keyboard shortcut for saving is the same for most software, which is Ctrl+S. You can close this tutorial by pressing the Close button on the Step Selector panel. Keep your part open, as it will be needed for the next tutorial. Check the dashboard on how to start the next tutorial.